All right, should be live. Hopefully the video works and the audio works and all that. All right, welcome back. So today I'm going to be working on some Wi-Fi issues. Actually, why are like the lights off here? One sec. Like the lights are too dim in my room. Yeah, I'm going to be working on some Wi-Fi issues, and basically until now we haven't really traced the Wi-Fi chipset, and we got Wi-Fi working because I can explain it a bit, but basically we don't have a tracer that can see what macOS does with the Wi-Fi, and to fix some issues that remain, we're going to have to figure that out. So I'm going to be making a Wi-Fi tracer, and we're going to look at Bluetooth coexistence, at access point mode, which is currently broken, at least with some apps, and hopefully at sleep mode for the Wi-Fi. So before I start, you may or may not have noticed that monetization is turned on for this video. And that's because I heard that some interesting people might be tagging along this time. And so yeah, I hope you enjoy the stream, and thank you for supporting the project. So let's get started. Let me just check a couple of things. All right. So, probably won't be a very long stream too, because I have some stuff to do tonight. But yeah, let's get to it. So I actually already started on. Well, I got a PCI Express sort of base tracer going last time when I was working on the USB issue. So we're going to reuse that. Mini trace PCIe mini trace. Do I want to create a separate? Let's just make it a hypervisor script for now, because we have trace as media. We'll just copy and paste that. Trace Wi-Fi. We're on. And let's see. So I don't actually know how the low-level Wi-Fi interface works, because when I ported over the Wi-Fi stuff, so here's the story with the Wi-Fi. The Wi-Fi chips on these machines are just mostly standard Broadcom chips, running some somewhat custom Apple firmware, and the main weirdness is that they have an OTP that you have to read to figure out what firmware and configuration you're supposed to use. But then also the newest chips also require some newer API versions for like some commands, like scanning for access points and stuff. And so it turns out that Broadcom already had these implemented in some other alternate like Android Broadcom driver that you can find the source code for in dumps in various places. So I just used that as a reference to implement them, which is relatively easy. And so it was basically that, the OTP, some PCI Express registers were slightly different, but those were also the same. Like they were also implemented in that Android driver, and also you need to load some calibration blobs. But the way those are loaded is basically the same as the way some other existing stuff was already loaded. So, like just by stringsing the Apple driver, you can see the like variable name they use for loading those, and then it's just like existing code that was already there. So basically, I didn't have to reverse engineer much of anything really to make Wi-Fi work. It was mostly just piecing together things that already existed and making it into a coherent patch set for the Linux driver. So today is when I actually have to reverse engineer stuff, because now we're stuck on the extra things we couldn't figure out from the Broadcom dumps and all that. So as usual, I'm going to be making a tracer for the Wi-Fi. And so I have this PCIe. Where am I? Let me just close some noise here. By the way, I'm on the Mac Studio again, because, why not? It doesn't really matter what machine I use for this. But also, the Mac Studio has the most recent Wi-Fi chipset, same as the M2 MacBook Air, I think, and the M1 Pro and Max laptops. So we'll get the full experience, so to speak. And then, if for whatever reason some things are simpler on the older chips, that's probably easy enough to figure out. So let's look at, where am I? Hypervisor, not here. Trace WLAN and PCIe, here we go. Okay, so I have this PCIe scaffolding that lets me trace register areas and the configuration space. We're going to use that. We'll call this WLAN tracer, start. We'll get rid of that. I don't know what bus device ID this is going to be in macOS. We'll have to figure that out. So I can actually just trace everything for now, and we'll quickly figure that out. And then we can get rid of this. I'll just copy that back. And it's not going to be that device number. So let's just run it one, tracing the entire PCIe register space. That's going to very quickly tell us which one it is. Mac 13J, that's our... Oh yeah, I was messing with DCP the other day with Sven. Log, let's call it HV LAN log, and load the trace, WLAN, and give that a shot. I think this should have... I think this is the usual, yeah, 12.3 macOS version, so that should just boot. Oh. Unexpected indent? Oh, because I didn't comment that out. Trace WLANs. So there we go. That's macOS booting, and also apparently I messed up the HDMI again. Hello. Yeah, there we go. Let's see if we get some stuff. Yeah, we get. Oh yeah, that's the USBs. That's not Wi-Fi. But there was some Wi-Fi stuff there. It's already doing some Wi-Fi stuff. Let me see if I can quickly figure out which device ID we have. So this is that looks like this one, to be honest, because this should only have, it has the SD card reader also. Well, I can just read it, to be honest. Let me just check. PCI. Actually, does it even tell me? It might just tell me. Wouldn't be surprised if it just mentions it somewhere at the top here. Maybe not. Let's see, the first mention is there. Start, Apple, PCI, something. It doesn't mention the bus ID. Okay, let's just do a quick read of that. That's actually easy enough. We're just going to get config space. So I always forget. Device ID is, oh, it is actually at 0. Okay, so yeah, I can just read it from here. Because it's going to be one of these simple ones. So this is going to be at, oh, it's going to be this one, because this is the function ID. So this is going to be Bluetooth, and the other one's going to be Wi-Fi, I bet. Yeah, I think that's Broadcom. (14E4). Yep, that's Broadcom. Okay, so we know the Wi-Fi is here. That is bus ID, what, 20 bits lower? 4, apparently. I thought 4 was USB. Is it just dynamic or what? Maybe it is dynamic. Because I thought we had USB here last time. But now apparently USB is at 1? That's kind of funny. Okay. We'll see if it's consistent. If it isn't, we'll have to figure something out to get it to dynamically determine which device it is. But that's unexpected. Oh wait, no, wasn't 4 what Linux assigned? Maybe, and then like I was testing Linux, and so it was 1 on macOS and like 4 on Linux, or that could be it. Yeah. So let's see. I don't think it was random. Last time I noticed that bus ID was not something I expected, but I don't think it was random. It was always the same. So we'll see. But yeah, now it seems to be 1. So let's say this is called a WLAN tracer. Go to trace as media. I don't think. Well, we do care about config space a little bit, and then it's going to be using several bars. So let's look at the Wi-Fi driver and see what it actually does, and then we can write a tracer. I can just kill this for now. I don't think we care anymore. Let's give it that WLAN tracer. LAN config space. Hey, thanks for the super chat, man. All right, so let's go to Linux drivers. I'm just opening it from here. Linux drivers, net, Wi-Fi, Broadcom, FMAC. Yep. And we care especially about PCIe.C, probably the H also. That's where most of the interesting stuff is going to be. Oh, there's nothing in H. I don't know what those changes are from. Okay. So we're looking for primarily the main control command ring, because there's going to be some kind of ring buffer for sending commands, in particular variable sets and gets. So there's going to be some ring buffer for that. We're not interested in data. So we're going to have to trace through this code. Actually, let me put it here on the more middle side. And let's, this is going to be driver reading time to begin with. And let's see. So there's this select core thing, which is changing the config space to determine where the bar 0 window is. So that's something we need to do. And that's actually going to complicate things, because it kind of means that the tracing has to be dynamic on another level than it already is. So we might need to add some interesting stuff to make the bar tracing dynamic. But for now, let me just search for that, see exactly where we are. That is just defined at the top. Okay, yeah, so these are the... I think these are all config space. Well, these aren't even used. Oh yeah, and this mailbox is the one that is actually used for, if I remember correctly, this is actually the thing used for sleep. Yeah, this is used for sleep in the existing driver. I don't think Apple uses this. But I would have never thought to make a framework around Python to help reverse engineer hardware. Yes, I keep telling people that, like, the more tooling you make, the more time you're going to save. And like every hour you spend writing tooling is going to save you many hours of time reverse engineering stuff. So highly recommended. Okay, so send mailbox data. We have the SB mailbox thing here. Yeah, we're going to at least trace that just to see if there's... We're going to trace all of these. I think... Yeah, these are all config words. So we're just going to dump these all in. Those are not config words, though. Those are... I think these are bar registers. Yeah, the BCI2, right? Those are part of the that space. So these at the top are the config space registers. So we can dump those in immediately. Let's do that. So we have bar 0 window. And I'm guessing these are all 32 bits. Door, yeah, I think these are basically all 32 bits. Wrapper base. I don't know if these are used for anything. Oh, they are. No, but these are... No, those are not in the config space. Wrapper base is not even used. But these int status ones are. Int mask and SB MBX. I don't know if that one is... Yeah, that one is also there. Don't know if it matters, but let's dump it in there, because why not? Status control, I guess we might as well tap this a bit more. This is BC. Typo there. Yep, that should be good. And also there were others for... Wait, hold on. Oh, those aren't used. Yeah, so that's fine. I don't know if... Wait, no, link status control is configured, so yeah, that's fine. Let's see what else. Bar 0 window, link status control. Okay, right. Config, see what else is in there. Mostly just bar 0 window and link status control, actually. Yeah, okay, so in config space, that's really all there is to it. Hopefully. So that takes that. And then the interesting stuff is going to be the command submission. So let's see if we can just trace the... if we can trace this stuff, right? So we... IOVAR data set, this kind of stuff is... is what it gets used a lot. So this fill IOVAR data set, it creates... It's just name plus data len. Okay, so it's literally just name data, null delimited. That's easy enough. And it doesn't delimit data. I guess that just is implied. And then command data, set var bufflen, proto buff. Okay, that's interesting. So we need... yeah, so fill command data is the interesting thing. Okay, proto set d command or query d command, and then it's command data length. So let's see what set d command does. That is somewhere else. That's in proto h apparently. Okay, so that's set D command, and there is an actual proto thing. So I guess there's multiple protocols: message buff and BCDC. And so which one's which? I bet it's message buff. Yep, it's message buff for BCIe. Just had a feeling. So that's where we're gonna get the interest. Now we're getting to the back end. So message buff. Let's go on the left here and look at both files at the same time. Query D command is apparently the same as set D command for this one. That's easy enough. There we go. And so then it's doing a transmit IO control. And then it's just looking for responses or something. So let's see what TXIO control does. Okay, there we go. So as I thought, yeah, there's a ring buffer involved. Common ring reserved for write. Yep. H2D message ring control submit. So that's going to be set here somewhere. Yep. So there's a control ring, and we're going to have to dump stuff in there. And I bet that is going to make things very simple in the end. So there is an H2D mailbox, but I'm not sure, I don't think that's the ring. And then there's doorbells involved. So there's common H2D W index host address. Okay, so there's this ring info structure. I seem to recall this actually gets written to the to somewhere. Init ring buffers. Ring info that actually reads. Oh, okay, so that reads from the shared stuff, and we need to figure out where we get. See, now it's getting interesting. We need to figure out where we get the shared data structure version. So this shared info, where does the address for that come from? Interesting. That's dev info shared. Where does that get set? I know I remember seeing this way back when I was looking at. Oh wait, no, this is just part. This is internal. Okay, so this is just. This just gets read from the TCM. And it's shared RAM address. That's, yes. Okay, so we need to get that address first. And let's see. So this gets the shared RAM address written. Ah, okay, that just ends up at the very end of the RAM size. So we need the RAM size. We don't want to go too deep in the rabbit hole just to figure this out today. So because I know the RAM size is kind of a pain to calculate, and doing that in the tracer is kind of a pain in the ass, we might as well hard code it based on the chip ID. Makes it a bit easier. So we're not going to go that far. But it should be pretty easy to figure that out. So read RAM 32, how does that work? That just does IO read 32 of the RAM TCM, and the TCM is which bar? That's bar 1. Okay, so bar 1 is the TCM, and that's easy enough to see. So we're going to... What I'm going to do, for now, actually, is let's just say reg map. Let's just declare a reg map. This is probably not what we want for bar 1, but for bar 0, sorry, for bar 0, but for bar 1 at least. That's just going to be the entire memory of the Wi-Fi. So what we're going to see there now that when I run this is we're going to see it write the entire firmware, which is going to take a while and be quite slow. But that's also going to tell me the size, and we should see it then read and do some interesting stuff with the other with the other bits of the memory. So I don't actually want to trace the whole thing because it kind of sucks. But yeah, see there, that's the firmware being written right there, I think. Oh no, sorry, do I still have I'm still tracing the whole thing? That's not firmware though. That's still the... No, it's USB still. How did I end up... Is it really dynamic? Huh. Yeah, if the bus ID is dynamic, that's going to be a bit annoying. I have to figure something out for that. Let's try bus ID 1, see if there's anything there. Okay, that's Broadcom, so I got it right this time at 4. Okay, some stuff happened there. And that's the... No, that's not the firmware. But that's something. I think those are doorbells already. Yeah, those look like doorbells. What happened to the firmware, though? I was expecting to see a firmware load. Let's see what we have. Okay, bar 0, bar 2. Yeah, those are the... bar 2 sizes. Oh, bar 2. Was it bar 2 and not bar 1? Did I get that wrong? It says bar 1 address, bar 1. Oh, but it's 2. Oh, because it's 64 bits. Because it's 64 bits, and 64-bit bars take up 2 slots. So it really is... Yeah, okay, it's the second bar, but it's bar address 2. Thank you, Broadcom, for being confusing. All right, but we can see that it's doing stuff in bar 1. Okay, let's try that again. What's my educational background? Kind of random. Like, I did take computer science and then kind of switched to computer engineering and then ended up doing something else. But I honestly, most of what I learned like by myself. Is this working? Yeah, it's just slow. Okay. Yeah, it's still Broadcom, so at least we're consistent there. I hope I can see the firmware getting written now. Yep, that's firmware. Not even slow. It's gotten better since Lena improved the bandwidth of the USB stuff. There we go. Okay, let's get it there so we can see a bit of what's going on. Yeah, so you can see it writing the firmware, and then it actually just writes and then reads back the same thing at the end. I thought that was supposed to be the pointer to like the NVRAM though, but I might be wrong on that. It's just that the firmware is in the same channel as the pointer to the shared information, and that's what I'm interested in. So here, read TCM. See, send mailbox data is using that, and then also there's also the console in there. But the one I'm interested in is this one, the shared RAM address, right? Yeah, so this is the firmware download. It copies the TCM plus the info RAM base. So the firmware goes at the top of RAM. Then it writes a 0 to the end of the RAM. That's what Linux does, by the way. macOS does not necessarily do the same thing, but then this writes the NVRAM to the bottom minus NVRAM len. And then there needs to be the before that there's that random stuff that Apple adds. So this looks like the NVRAM includes the padding at the end. Like it needs to have a word there. Because you can see this is ASCII, right? And this actually wrote the whole thing. So it wrote Isn't this wrong? Isn't this writing like actual data, or is that just some kind of footer? RxGAI? RX gain. That's like RX gain. I think that's uninitialized data. I think this is just Apple's love for uninitialized data, and it just it just writes that. Yay, Apple. Okay. Okay, so then it writes something there. Shared RAM address written. And then it waits for that to change. Yeah, the stuff before is ASCII because this is the NVRAM, but like it terminates there at 0, and then there's like more ASCII, but that's just uninitialized data. So it writes that. Then it writes something else which might be about booting the firmware or something. Actually, isn't that like the top of RAM? That's kind of interesting. So NVRAM is this blob, which you can see there. And then there's that little header. And this is random data. Yeah. So you can see the random data starts at 80, 935, 80. Then the actual NVRAM starts at 935BD8. I thought the NVRAM was supposed to have something interesting at the end. I think this is in firmware.c. Where is that? Yeah, new length. It puts the token at the end. That's the new length divided by 4. It does a word swap for whatever reason. Oh no, it's okay. Yeah, okay. It's like checked. So DO9 is the length. So this is okay. This is the NVRAM length that goes at the end of NVRAM, and then it's waiting for that to change into the address. Yeah, okay. So it reads it there. So that means the firmware has booted, and that is the shared, and you can see it actually reading from there. So that's what we want. So we're going to do that here. I don't want to actually trace everything because of the firmware. So we are going to look for reads of this register and update the RAM base. So we might need to add some hooks for this. PCIe. Update tracers, trace bar, yes, trace bar. So we're going to override that. If index equals 2, that's not equal to return super, well, it's not return, just, I don't know what return. Trace bar, index start size, just keep those the same. And then for bar, let's just say we need the RAM size, which is a funny size, as you can see on these chips. Just find that 98A. The top of RAM was the top of the bar is 1 there. Actually, do I have the RAM start somewhere? Let me actually just for documentation purposes. Yeah, so RAM starts there. Is that an unaligned address? No, it's aligned. I mean, it is +1. Just so 5C17. The bar should start at 5C1. And then RAM size would be that minus, yeah. So yes, it's definitely a funny RAM size. Yeah, it's like 4K aligned, but it's weird. Though I think it's not necessarily like literally the size of the SRAM, but like it's the size of the area allocated for this firmware stuff, and then there might be other, other things after it. But as far as we're concerned, that's the RAM. So the trick here is that we are going to not. Well, we could just trace regmap, yeah. So it makes life a bit easier if we do that, yeah. So we're gonna say WLAN. Yeah, so WLAN RAM and I'm just gonna make this a single register because it's a bit easier. Shared base at 00, register 32. Actually, they call it TCM, so let's call it TCM base and TCM size. Actually, no, those are S. I think TCM is TCM is the whole bar, and SRAM is I think only part of that. So don't need that print anymore either. And then if it's this one, we just trace regmap, trace bar, start size, but it's not start size. Start plus SRAM base plus SRAM size -4, only 4 bytes for that. The regmap is SRAM end. It's not SRAM and SRAM. Actually, don't even need a prefix. And so that should give us just that register, which is much nicer than that. And so here, I can just say none for that because this is going to override it anyway. That gives us what we want for the SRAM base. And so now, probably in this PCIe tracer, I want to actually just make a little array for that. And just have it store it here, so. Actually, I can use iRange for that. That's nice and convenient. Well, to be honest, I can. Yeah, I don't. Well, I mean, also keep that, but I actually just want to set it here anyway. And I should set it on state. Yeah, just keep it there. Makes it easier. So that gives us the shared area. And then unsupported bit flag, supported bit flag. Yeah, this is also useful because it tells us exactly what. We'll see where it's reading this actually, because I don't know exactly how it's checking for these caps, but we care about that, so we'll see. So this FFC is the shared area. It does a read. So what I'm going to do is we need. Let me just look at another tracer to remind myself how this works. Yeah, like that. It's just W whatever. So when we write the shared base, and we're going to call that a tag because that's what it is. Equals tag. So when we write the shared base, that's actually the tag getting written. I should check if Linux is going to do 64-bit writes for that, because that might screw this up, but we'll see. Don't necessarily care about tracing Linux, though, to be honest. Wonder how long it'll be before some engineers at Apple create their own Wi-Fi chipset. Who knows? It might happen. So then we read. Yeah, so we need value on that. And then on base, if base.value equals state nvram tag, don't do anything. Otherwise, because that's when it's polling. Otherwise, state shared base. Base.value. And now we know where that is. So the next thing is that I actually want to make sure that I trace this in sync mode. Yeah, because I'm not going to be tracing a whole lot of things, and I might want to read memory myself just to do everything in sync mode. It shouldn't be that bad. And so now that we have the shared base, I need to read that. I also should actually just do a for init state. I probably want super.init state and self state shared base none state TCM size none nvram tag. And then in start, we do update tracers. And update tracers, let's do update, instead update TCM tracers. And then here, I can just say TCM base. And so this is so that it works when we reload, and I don't have to keep rebooting every time. And then in update tracers, do the super updates, and then update TCM tracers. So then if that is set, then we add that tracer. And then we can just call that again when we set the shared base. Oh, we don't actually have to set the shared base. We can just do the reads here. Then in start is probably what I want to do that. then it wouldn't be update tracers. So just do it in start. Instead of an update tracers, I'm gonna just do it here. So we start super update TCM tracers, update SRAM, update shared. Doesn't really need to. Well, to be honest, if we already read it, we might as well. I'll still reread it though, so we can just do that. So when we set the shared base, we call update shared, and then we get the shared base out of that. Don't do anything if it's there. And now we can... we should actually just use a reg map there. I don't think we care about tracing it. We just need to read it. So we can use a reg map for that. Shared data is there. Shared info. TCM base address flags. You know what? Not even a reg map. I want to use construct for this. Yeah, let's do that. And so we have, yeah, let's just translate all of this here. Flags. And those are pointers. That's an array of pointers. Okay. So it's actually wait, pointers? No, that doesn't make sense. Sorry, this is not the no. I'm sorry, I'm confusing myself. This gets read from the shared stuff, but not directly. So I don't need that structure. But I'm confusing myself. Yeah, this is what I want. Okay, so address 0 is flags. Yeah, construct details. I did fix that. Okay, so it's these variables actually. So we might just want a reg map for that. Yeah, I think we just want the reg map for that. So I'm actually I take that back. We're using a reg map. Because it's easier in this case. And I can actually just paste these and do a bit of regexing. And we don't need the offset things. Actually, just do it like that. Okay, that's more like it. Hey, Dreamer. Okay, and so now I probably just want to dump that on init. Utils, like map. I think we did have a dump for that. Yeah, dump regs. WLAN slam shared. And that base address thing is just relative to the base of the TCM, so that's fine. And then we instantiate that. I think we just pass, if I remember correctly. Backend base, yeah. HVU, and the base would be state TCM base plus base. 959 typo in state. Good catch. And let's just dump it. Is there a dump breaks? No, it just goes to the standard output. But that's not gonna go in the log, but that's fine. Let's have log. Reading shared info. Okay, let's see how far we get with just that. And while that reboots, let me go back here. And so we have, I don't care about the console. We're going to ignore the versions for now. But the ring info address, I bet there's going to be more stuff there. So, yes. So there is, in fact, a ring info structure there. That one. I like how they call it dongle, like, you know, as if the Wi-Fi thing were a USB dongle, but they've stuck with that name for everything. Okay, so let's make up another ring info. SRAM ring info. And then we have ring mem 0 32 our index pointer D to H, D to H, and then we have H to D index host address. I guess we do need a bit more tabbing here. Our index host address D to H. Just fits. Oh, those are structs, sorry. What are these structs? Message buff address. Where is that? That's in message buff.h. Oh, it's just 64 shrug. No, this actually gets copied from the hardware. You can see it Well, first of all, anything that has LE32 and stuff is pretty much going to be hardware, so. But this actually gets copied, so. From the shared ring info address. Okay. I just need offsets for this. 8, C, 10. Ah, it's not even aligned. Lovely. That's probably not going to work. Because I bet they... Wait, no, it will work for... No, because it's not memory. No, it won't work. Okay, let's just split it. I can live with a split. Actually, can I cheat? I might be able to just Now, the LEB stuff are just markers, mostly so you get compile warnings if you use them without endian conversions, I think. I think there's a linter that checks for that. It's not... It doesn't actually do anything interesting. It's just documentation, basically. So the... reg map accessor, I think, just goes through util. Yeah, it just does write and read. Yeah, read and write on the back end with a certain width. So that's in proxy utils. So I don't want to make the like regular read 64, write 64 stuff and like support unaligned addresses because that is kind of painful. Because I want to catch those when they are wrong, but I think there was a PR that touched this at some point. I might just add extra things. And that should probably go in proxy utils. Yeah, so because the most common case is just 64 bits getting split up. I don't think I remember seeing anything crazier than that very often. I'm going to make a special case for that and just say that these accessors support that. And I'm actually going to say if dir and for do it split, else we can use a 64-bit, right? And then I'm just going to do a read 64x, read 32, else read 64. That makes sense. And so now I can pretty much just say actually let's just call it you write 64 and you read 64 for unaligned. You might optimize this later at some point, but for now this is gonna be good enough. Yep, that works. And that should fix this. And then I don't need the, sorry, and then I don't need to split that anymore. So that makes life easier. 14, 1C, 2, 4, 2C, and then max flow rings would be 3, 4, 3, 8, 3C. So the ring info stuff is that is based on TCM plus ring info address. So that's easy enough. Ring info, so we can just set that. SRAM shared SRAM ring info is TCM plus self shared ring base, was it? Ring info address. State shared info address val. Let's see how badly I messed this up, because I haven't been testing any of this code. But this is getting us pretty close to the stuff we want to do. And I might not even need, because it's all ring buffers in TCM, so I might not even need the funky bank switching stuff to make this work. Hey, it runs. At least it compiled, so that's good. Whoa! That didn't work at all. Trace mode and string. What? Did I just mess up the... Oh, yeah, because this is like name SRAM. Let's see what we get. Okay, what that is. Okay, there we go. Now some interesting stuff happened there. Shared base, alignment error. Did I mess up? Oh, wait. 40? Are some of these numbers like unaligned or something? Oh, some of these are 16 bits. Wait, why are both of these 52? What? What? Ring base offset isn't used. I'm gonna say that's a typo. And max ref buff post. Those are 16 bits. Okay, that's why. And RX data offset is also 16 bits, I guess. No, that one is actually 32. Okay. But I should be able to just do it almost. Utils. Proxy utils. Oh, read does not take data. Hey, and now it works. I love this reload stuff. Excellent. Apparently the host addresses are 0 anyway, so much for that, unless I messed up and didn't return it properly. Let me do a quick... Oh, they are 0. Okay, so much for that. And I think these are pointer bases. So what we're going to have to do, I bet, is... probably just trace specifically a certain offset from these. Okay, give me a second. I'll be right back and get some water. Okay, should be back. So would it be odd for a PC device to know where the host address is, given there is an MIO translation? On many platforms, there isn't an MIO translation. The bars directly specify the host address. On this one, there is a translation, and that's why you can see here that what the device thinks is this address is actually this address on the host. However, these addresses are all relative to the bar base anyway, so these don't even include the bar base in them. These are actually just relative to the beginning of the bar, so they are not actually. These are actually addresses in the address space of the firmware of the Wi-Fi, which is then offset from the point of view of the host. So let's take a look at what we need to trace those rings. So in PCIe, okay, so there's one case where it just reads those. Otherwise, it's reading those from ring info. Wait, hold on. Oh no, it's just the pointers then. The main index size. Otherwise, it reads index book buff DMA handle, whatever that is. Looks like some kind of base address. I don't think that's what we're using. Oh, it just does DMA coherent. Sets a thing called index buff. And it can be in TCM or in host memory. That's why. Okay, so it can be in both places. And then DMA index size is set where? Oh, okay, there's flags for that. But I don't. So again, I guess this would write the host addresses then. Yeah, and then it copies it back. Neat. Okay. So in that case, I actually want to trace that SRAM ring info thing, because it looks like it might write to that. How big is that? 40. So ring info. So I can just run that again, and that should be tracing. Okay, so it does use host map indexes. Neat. Neat, but somewhat annoying because it means that oh wait, no, but it has to be a doorbell though. No, the trick is that there's gonna be a dart involved now, and these are gonna be relative to the dart. So we need a dart. And yeah, because these are 32 bits, it's actually low and high. But I don't think the highs are going to be written by anything other than 0, because I think pretty much everything will use 32-bit DMA with the darts anyway. So I can probably just ignore that for now. Okay, so it's just that tracers from when those get written, which doesn't mean I need to reboot to get that again, because I don't feel like redumping it, but so then we need a doorbell. So you can see there's a 2140 there. I think that's going to be somewhere here. What is 2140? There's some other stuff here, some other structure too getting written. Wonder what that is. At 2610? Must there be something pointing to that. And that's not even in... Oh, okay, wait, that's not... Those are like actual registers. That's bar 0, isn't it? I think that's bar 0. Yeah. Um... Doorbell, doorbell, doorbell. Is it these mailboxes? Yeah, ring bell. HTTP mailbox 0. Yeah, there we go. 140 is that 2140 thing. And so I think that's in the fixed area of bar 0, so we can afford to make it fixed. And that's the only trigger we need. So then the only tricky thing is that we do need the Dart to actually read the data and the host addresses and everything. Okay. So in bar 0, so align those. config data. Okay. That takes care of bar 0. We don't need TCM anymore. We're not tracing any of that individually. Oh, and then there were 64 ones. Interestingly, this is not using the 64 ones. I thought we were supposed to use the 64 ones, but I guess... Well, that's interesting. Maybe there's some setting for that, because... I thought this chip was supposed to be using the 64 interface. At least that's what Linux does. Interesting. Okay. I wonder what the value here is. I wonder if it's like an offset into a ring buffer or actually like a timestamp or something. Or it doesn't really matter. So what does it actually write to the mailboxes? Oh, Linux just writes 1. Okay, so it's probably just like a timestamp or something. Oh, hey, thanks for the super chat. GR Bugs. Thank you. Okay, so we actually care about the common ring. The common ring is which one? Common rings and flow rings. So the indices are in the H2D stuff, which actually came from the host address. Address. Okay, so the pointers look like they're relative to 0 in this case, and then I'm guessing this DMA stuff checks for write pointer, read pointer. Okay, yeah. Oh, okay. So then the TCM, yeah, index buffer. Yeah, okay. So those are just using MMIO, not MMIO. Sorry, like DMA memory. So we're gonna have to read DMA memory for that, which means you have to translate the addresses that this writes. Are they all these on the same page? No, they're in different pages. Interesting. They're all different pages. So I guess they're all different buffers for this one. Linux seems to use a single allocation. Um, Okay, so we need a Dart. Let's do a quick experiment here before make sure I get it right. Get mini proxy client. So APCIe, yeah, they're separate darts. Yeah, there's 312. And 0 is Wi-Fi apparently, so that should be easy. This is a T6000 dart in this case. So let's say don't really need a dart tracer, just a dart really, but so this is in hardware dart. We do have a dart. Ranks. Oh, it's just, we can just dart from ADT. APCIe 0 was it? Yeah. Instance, I think that's 0. Hopefully. Util. I don't need util. Yeah, I should do it. And pass it to the tracer, and then in here, PCIe. Just do another init override. Init HV. And you get the dart, and let's try instantiating that and seeing if it works. Can I just dump everything? Dart. Not the tracer, it's just hardware. Dump all. Yeah. We've got maps. And so these here that we saw, the buffer addresses at 165C are indeed mapped 165C. There we go. So that's just raw. There's nothing fancy there, and that goes to the right hardware address. So I can just use IO read and IO write in these. Those are device 0, I think. Oh, 1 apparently. Okay. Just hard code that for now. And so then if I just do IO read here from the didn't we have something for no, we didn't for like that was only in T8110. So if I read this thing here, there's our pointers. Excellent. I probably just want to translate them right here. And hopefully they're on the same page, but we know they are in macOS. And so now I can just read them, write them normally. And so then I think the indexes are just consecutive there, and we need to know what the rings are. So PCIe, it's just the list of common rings. Yeah, so it's control RX post, control submit, RX post submit, control complete, TX complete, RX complete. But these are write and read for host to D and D2H, so only some of these are. Yeah, so H. This one is which one? H to D and then D to H. Read. Yeah, so the indexes have to be only a subset of them, I guess. Max submission rings plus max completion rings. Yeah, so it just sets common rings I. Number of HTTP common message rings. Okay, these are probably here. No. That's in bus. Okay. Okay, so there's just 2 common H2D message rings and 3 common D2H message rings. So those are the only ones we care about, and then somehow H2D starts at 0, but control complete starts at 2, which is weird, but okay. Sure about that? 5C60, 5A60. Oh, I guess it's just looping around. What IDs is it using exactly? Yeah, it just adds index offset, which is whatever DMA index size is, but I think those are 32 bits. Okay, so it does it has the HTTP common message rings, and it has separate pointers for them. Okay, so it does do them consecutively. So it's not the IDs that matter, it's just the number. Yeah, so it's just 2 and 3. which means it should just be the 0th entry for the control ring, I think, on both of them. Because flow ring ID start, that's the issue. Okay, yeah, so it's just these. Okay, so, and now, how do the ring buffers work? Or was that? I thought there was a flow ring. I think these are just for the flow rings. Message buff might be a bit easier. So let's look at the... Oh, no, this is actually just the buffer stuff. Okay, let's go back to the tracing the protocol. That's in here. That calls set D command. That's the same as query D command. And then TXIO control. Okay, so it does a reserve for write. Is there a common ring? Oh, that's where it is. Okay, this is the ring buffer implementation. We know where the pointers are. We know where the bell is, the doorbell. So now we just need to know the item length, which I think was constant, and set here. I don't know if I'm going to care about tracing anything but the common ring, so I might not subclass this and just make it a bit simple. Though, man, yeah, I might as well subclass it. Why not? And not subclass it, I mean, make it a separate class. Doesn't really make it much harder. So, the rings, common ring, where is that? Control submit item size. That's in, where is that? Here, 40. And complete is 24. So those are the ones we care about. Traceable LAN. Let's see. That should be fine. Ring tracer, IDX. There. X false. We're only going to go for transmit for now. And then we do class LAN control ring tracer. Control submit ring tracer. Actually, SRX, we can just have that in here. And then 40. And then, yeah, because we do have submit and complete, so that's nice. Complete ring tracer, 24, RX true. Actually, we can just kind of hard code the indexes here. So you know these are 0. And we're going to need a self-state thing here. It's similar to what Lena was doing with the GPU rings. Self-state, WLAN state, rings. So we need, let's put a rings here. Let's go to, yeah, we'll just make it rings. And get Actually, let's say if in state rings, then substate equals it's got ring ID. Ring ID and state rings. Then we just clone that. Else. Yeah, otherwise just make a blank one. We just make a class for that. Can be empty. And we just say, keep track of the Rx pointer. Hopefully starts at 0. That should be good. And then def poll. Actually, sptr is self wlan if self dot rx. If it's an rx wlan dot host to device, actually more like right pointer, sorry. BTR, sorry, state rptr. PR itself wlan h2dw index. And you can just read 32 that. Let's get a P in there, the proxy. So if it's a receive ring, sorry, if it's that's the else. If it's Rx, then it's D to H, right index HA plus, yep, otherwise it's H to D. And then we read. We're going to want the self log. Def log self message self dot roland dot log self dot name message. Okay, and now the rings. Where's the data? We know the item size. Where's the base? Buffer address. Okay, how is that configured? Does this get called from here? Yes, it does. Alloc DMA and ring. Okay, common ring. TCM ring fits address. So it doesn't init DMA buffer. What's that physical address thing? So is it actually mem base address? Oh, is it? It's just at the top of memory. Missed the closing parentheses. Thank you. What is it doing here? This is the ring mem thing, which it does read, and that sounds relevant. Yeah, that's ring memory pointer. Okay, so then it actually just does... alloc DMA and ring. Where is that? So it just gets the index on there. Wait, what? Okay, so that ring mem is the base. And to that, it adds the ring mem base address offset. And then it passes that to common ring config. So we're going to need to figure that ring mem thing too. So we also need another tracer there. So we need another reg map here. I think that was 32 bits. Okay, then it writes max item and ring item size. But in this case, it's just writing directly to the ring ID. But is this actually getting incremented? Oh, it is. Okay. Ring mem size. So there's 16 bytes there. So I can actually just make this an array. If I remember how to do that. I think it was... how many rings do we have? It's 5, so... we're just going to do the common rings, max item, I range 4, and count at 10. And so that will give us an array, and then I can have a single reg map to trace all of this. Okay, so now in the ring info, Trace the ring mem. Ring mem is already in the TCM set, so I think we just read that. So we need that one. Call that ring mem base. Ring mem base would be shared ring info. State ring info. Ring mem val. Yep, that should do it. Ring mem, dump everything, and then we trace the ring map also. Ring mem base. In this case, I'll just do command ring count times 10. And ring mem. And pretty close, because that gives us the ring info stuff, and then I just need the address. So base address is at 8. I'm guessing that gets written. That looks... No, that's those are registers. But ring mem is 906, 905.684. I think it's just because I'm not tracing that. So let's do a reboot and see if that works. And I think I'm getting there. It's only 2 hours in. Invalid syntax, comma. Invalid syntax missed some colons. Exception occurred. Oh, because this Dart isn't quite there yet. Okay, let me reboot that. Because this is gonna try. Yeah, the APCIe darts need to be enabled, so I'm just gonna pass the Dart in there, and then in the in update TCM tracers, I'll just do it here. Self Dart is none. Self Dart equals .20t. Dart path. Dart dev s1. You can hard code that. Yeah, that should probably work. Hold on. Self Dart is none. Initialize it, but then only instantiate it after the TCM base is set, which means the device is up. Okay, let's look at that. Woo, no attribute U. Oh, I thought I was saying those. P. Yeah. Okay, tracing bar 0. Interesting. Some stuff happened there. And now let's see when it initializes. Woo. I'm translating. Missing one. Oh, yeah. I am just going to make up some nonsense for that. Doesn't actually matter in this case, because they're on a single page and they know that. Start and register 64 and int. I am read 64ing something that I didn't do .val somewhere. Oh, here, probably. Yeah. Value, sorry, in the case of reg64s. This is not an accessor. Okay. So what do we have? Ring mem is all 0 at this point. But then this has to be writing to that. Yeah, look at that. It writes to that. And the base address is also a host address, so that makes sense. Okay, so let's make a rings thing here. 0, 1, 2, 4, 3, yeah. So the ring IDs are, you have the control submit one. This is our exposed. We're not going to implement that. And then we have control complete. Okay. And so now I can have interesting, there's other stuff getting written there. I don't know what those are. Are those the IDs? Those look like the IDs. But I wonder if this actually writes those or not. It doesn't look like the Linux one actually does anything. It just writes the base address and the max item and len items, so I don't know what's up with these, but they look like IDs or something. But it looks like that doesn't matter, so we're gonna ignore that. Basically, once max item, len items, and base address are written, and also len items hopefully match 40 is 628, yes. And this one is 18, which is 24, yes. Okay, that's good. So now item size. So in this case, index. Those are for the doorbells, but That's fine, do it like this. Let's call it pointer index instead, though. Let's take all of those. Set item count. Actually, just count because. Let's wrap these to make it a bit easier. .dev address size. And now self hard pointer item size. So let's do the instantiation here first. Def w max item. And we need some state stuff. This is like index val, I think. I think that's how it's done for the tracer when it has. Oh, it's value index. Okay. Now index. Ring info val index. Let's just make a class for that. Let's call it item count. Set item size, space address, and count. And then we can check for ready. And then we can just have an info thing here. Info dot item size, base address, count, info count. And so now when these things get written, we just set default this to ring info, let's do that, dot item count equals val dot value. And then do that for all three len items. Does it just count? It just count. And then this would be base address. Okay. That will give us the ring information. And then finally, let's do it like this. Info item size, value, info, base address. And then rings, which we're not using yet. update ring index. And then in start, we can redo that. It should be rings. Update everything on start. If index not in self dot if index in self dot state dot ring info, actually not in continue break, sorry, return. If we do have that, if not info, is it ready? What I called it? Return. And then finally, if index in self rings, we already have it set. Hopefully it didn't get updated. And finally, self.rings index equals, well, actually more like, if index is greater than self rings, return. And class equals rings index. If ring class is none, then also return. Otherwise, finally, self rings index. Ring class self. I think we needed that and info. Oh, hey Joey, thanks. It's going pretty well. I think we're getting there. And then finally, I just need to poll everything when we get the doorbell. So let's just poll ring 0 for now, make it easy. Oh, hey, Z. And we also want to do the completion rings, though the completion rings should be polled on interrupts, I think. So we'd have to trace interrupts. I'm not sure I want to do that, though. So I might just cheat and say that we pull them on whenever, like, we could trace the right pointers and stuff, but I'm just going to make it a bit easier for now and say that we do those two. And so that means that we'll get the reply to a command when the next command is sent, but like that doesn't really matter. Also, it should be in this order to make more sense. That's good enough for now. Then finally here in the poll implementation, we get the offset is read pointer times self item size. Address is self base address plus offset. Data equals self lan IO read address comma self item size. Let's call it packet data. And then finally self state read pointer. Set read pointer plus 1. Sent self count. And that should do it. Then we get all the packets. Def packet self data self log got packet. C hex dump. I think that has a print thing that I can use to send it to the hypervisor log. Yeah. C hex dump data print n equals self log. Let's see if we can see. I mean, this might actually be enough to solve all the mysteries if I can just read the. No, because these commands are fixed size, so they probably have a pointer in there somewhere. Yeah, let me just take a quick look, see what to expect. Common ring, right? Yeah, so that's just that. The will does set d command. That's in message buff, was it? No, that's in common ring. No, where was that? Oh, sorry. Yeah, it's set d command. Yes. Query d command. That does a txio control. That's reserved in the common ring, and then the message. Yeah. So there's a specific structure for that. That will probably have to go through construct utils. And that specifically has command output buffer. Yeah. And then there's an input buffer. Yep. Okay. So we'll have to figure that out. Let's do a quick run and see how that works. And then we add that extra layer. See, the thing with these interfaces is it's always layer upon layer upon layer upon layer upon layer of stuff. Thankfully, I'm kind of used to dealing with frame buffers because Apple loves those. Okay. Although this is Broadcom, but yeah. Not that bad, though. Not even 300 lines of code yet. So, hello. You can start up. It's kind of slow. The Mac Studio just takes forever to initialize, like all the USB ports and stuff. Let's see. Use the compiles. Okay. Not reset default. Ring info, isn't that? Oh, sorry, not ring info. Because that's a different thing now. Yeah. I want. Yeah, we want ring info and ring mem to be just nuns here. Let's get ring configure. The ring info data. And then these can just do that. Let's see if that works. Has no attribute rings. Oh, it's not self. It's self state. Is that? It's not state though. No. That shouldn't be state. That should just be like that. Woo, index. Pointer index. Pointer index. Okay. And then D2HW index HA. It's in state. State. Run it again. And now we have a none. Why is that none? That should have been written by now. Did we not keep that state? Or did we fail to IO translate back then? Maybe it wasn't already. Maybe it wasn't map yet. Tracer dot state dot. I think that's what happened. Yeah, I bet these weren't mapped. Okay, so we can't IO translate these. Gonna need a reboot on that then. And so then I can just do an IO read on these. Self HV, self VLAN IO read of 4. H2D. And then I can just say extract unpack. That should work. It's not going to work now, but let's try from the beginning. All right, one more time. What just happened there? That just died in a really weird way. I have no idea what just happened there. I don't know what that was about. I blame USB. USB gremlins. Okay. No, yeah, it's no rings anymore. Guess we call it's not state. It's self rings. Huh? Oh no, we do need state. We do need rings in state. Because that's the state for the rings, not the rings themselves. That's okay. That should take care of that. And I need to import struct. I can just do that. Don't even need to restart for that. I should do it. Or not. I guess not. I thought that would put it in the globals, but I guess not. Let's try that again. Hey, we got packets. So it submits 3 control packets with different stuff. It gets a completion. That might be a count. Maybe it gets more than that. Submits a bunch of more packets. Gets a completion. Submits. Gets more completions. Yeah, I'll have to figure out what these structures are, but this is working. All right, I'll be right back, and we'll start decoding these in a minute. Just one sec. All right, back. So time for decoding these things. So now is when I do want construct details. Because now I'm going to start getting a lot of interesting data structures. So, request, IO control, rec header. That goes in the common ring. And there's message types. So now we need one of those funky selects. So there's a common header. And then there's specific types. But it looks like it's really just going to be two types: IO control and there's IO control responses. Yeah, there's a few. Okay. But for the most part, it's going to be the IO control things. So let's do a quick manual check to see what's going on here. So the message process, message type, if index flags reserved. If index is that, yep. So the message types 1C. That doesn't track. I control pointer rec 9. I'm getting 1C. BD. So that, and then there's like buffer posts. And then there's command, and trans ID is 16 bits, but I see this incrementing. That's not right. Oh, there's a request ID. Okay, you know that. Hmm? Oh, this is weird. Unless they are using like a completely different interface from what Linux uses. There's lots of Ds. Event buffer post. Nine B, 1C. Yeah, it's like IDs I haven't seen yet. Are these just extended? Hold on. Where's that funny? Is it here? No. Hold on. I'll sit here and Broadcom DHD. No. I'll find that. VCM DHD. I think that might be one of these. This is from when? 2 years ago. Yeah, that sounds about right. Let's see if let's see if we have the types here, and we have more. And there's actually like comments here. Like this is actually better commented than the Linux driver, which is sad. Okay, where's the message types? Yeah, that was a nice comment. And of course, there's more message types that that we don't know about in Linux, because of course. Yeah, so these are right until 14, and then this, okay, so what we are actually seeing is 1C ring create. Okay, so that's creating a ring. Yeah, we don't care about that. And then control response buff post. So these are the ring creation stuff. Yeah. So it's actually creating more H2D and D2H rings. I hope it's not creating like more rings for the control commands, because that would really annoy me. I have to add another layer for that. What is this used for? The buff post? This looks like it's for... It looks like it's just sending some buffers or something. And then D is event buff post. Yeah, that looks like it's just creating rings. 1E is create completion. And then D is event buff post. Yeah, I don't know what that's doing, but I think we don't care about that. And then 9, 1B, 1C. Yeah, it's creating more rings. 24, 23. Mailbox data. Oh! See, that's interesting, because the mailbox, there's another mailbox thing used for the sleep stuff. And now I wonder if they're just tunneling it over rings now. That would be pretty easy if that's what they're doing. Okay, I have to take a note of that one. And then we have A. Okay, so that looks like it is actually an IO control. No, that's a completion. Rec AC. Okay. Oh, there was a 9 there. There is a 9. Okay, so this might actually be an IO control. Yes. Okay, so we do have what we expect. We can probably ignore most of those. Just decode the IO controls. And the maybe the mailboxes. So let's go to trace WLAN. And let's make a nice class for that. I think these are pretty much the same for all the rings. The only difference is the completions are gonna have like different lengths and stuff. Ring message. Construct class, subcon, actually class, header construct class. Let's make a header for that. Yeah, and we'll go with these. Type if ID let's make it signed, so -1 is like no interface. Epoch, apparently. That's interesting. And then request ID. Whatever that is. And now ring message struct header is a message header. And now we need one of those fancy selects. Payload. So constructs Python. How do I do the switch thing again? Switch is what I want. Xdump greedy bytes. That is not a call. And so now let's do the ones we care about. I control pointer rec. And let's also do the mailboxes because I'm curious about those. Does this use those at all? Do we have those? Interesting. It is in message buff. Where is that? That is in message buff. Okay. So it's just mailbox data and padding. We're not asserting the end, so we can just ignore that. Okay, so there's different. So that one is just yeah, H2D is just value or just even data. That's really all there is to it. And for D2H, there's some more fun stuff. Oh, there's a completion message header apparently. Let's make a compile message, compile header. Oh, there's a union. Ew. I don't think we care about the packet ones, so we're gonna say status. And there's a ring ID. Completion header, data, and some whatever that check something is. I don't care. Not for our purposes. I don't care. I'll go with that. And so the commands are H2D mailbox. So we have 9 is out control request. 2.3 is H2D mailbox data, and it's a D2H mailbox data. And then IO control request, we need that one also. IO control pointer request, is that what it is? IO control. Yeah, it's IO control pointer request. So that one is, don't have that one yet. I control pointer request. Oh, right, yeah, these are, sorry, thanks for that. The sizes are wrong. 16, not 64. And this is int, not in. Typing things. And then the control pointer. We do want the completion later, but okay. Colon header commands trans ID input bufflen reserve Oh, Netcat says, it's my first day on the job as a vulnerability researcher, reverse engineer. You're working smartly to follow this path. Wish me luck. Good luck! I hope you have a lot of fun. Okay, and so now the buff pointer. Thank you. You're welcome. The buff pointer, I'm guessing these are probably just input and output are concatenated or something like that. Let's do a check in here. Um, TXIO control just sets the buff address to the IO control buff. Buff input bufflen is just a min on that. Output buff is the full size. Oh, so it's probably the same buffer for both input and output. Yeah, that's probably just what it is. Yeah, so then there's going to be probably the max of those two as the input and output, but then there's this max message size thing going on. Where is that? Well, input bufflen is just that. Yeah, so we don't even care about that. We can just look at the actual lengths. And so, got packet equals ring message dot parse data. And then if I'm just gonna put the ID somewhere here. I control. No, probably want it in. Yeah. I'll just use the magic number for now. Packet, header, message type. And we're going to go back to the WLAN for this. Self WLAN, IO control, what are these called? Exactly. Control point direct packet. Elif, we'll just dump them for now. Got packet. You can just log the packet. And then we can call this function. We'll have to do the completions later. Let's see if, actually, just do a quick check to see where those are. We have 9 as the first one, and we are looking for, A is ACK. We got a 24, though. That's not quite right. They got an A is an ACK, okay. And then C is a completion. So 9 had, it gets the 23 act. But then we got a 2 there, which is weird. I control completion gets what buffers? Packet ID is request ID. That might just be like one of these zeros or something. Hold on. We had the trans ID maybe, command 601. Trans ID is 0 here. That's probably just what it is. And then that one, yeah. And then we have the lengths. Yep. Okay, so let's, I think we can ignore the axe and just handle those. And then let's also implement the completion structures. IO control response, that one. So we have command, no, we have a completion header. Response len trans ID command and some reserved stuff. So that one, I control resp. I think that's the one it is, complete. Yeah, so that's a C. Get rid of the underscore, I don't like it. I control resp. And then in C, we get control rect packet. And then back in the main tracer, let's put these in here, I guess. I control pointer rec self packet. And then we have response. And then so in state, we're going to do IO controls. Let's make a little state structure for pending IO controls. Might not actually need that though. I think we do, yeah. And so we got the packet. Just go back to my thing now because I think save. I can just look at the structure there. So The packets I think are already logged anyway in here. Got packet, yes. So then I can just host input buff address. Input buff len. Control packet. Input. We can just log that and say state IO controls data.trans_id equals packet. And then in the response, I control packet output, and we read the rec output buff len data affected payload trans ID, sir. Payload trans ID none is none. I don't have that. And then data IO read. It's host input buffer, but I think it's the same buffer for both. And then we just get rid of that in the state structure. String state. Let's see how well this works with without even reloading. Oh, switch, yeah. Ooh, trans ID, bytes object. Oh, not data trans ID. Sorry. Packet trans ID, and this would be RIC trans. Well, it doesn't matter. Packet payload trans ID. Exception of reading shared info. How did that fail? That didn't go well. Error missing. Yes, thanks. Let's forget that. Self-address of how did it end up with I got something though. Oh look, it's loading the CLM. So some stuff works. Yeah, okay. So this is working. Ring message, yep. Does it like unmap the shared info? That doesn't make a lot of sense though. Oh, no, it does work. Okay, I don't know what happened there. Oh, it died. Handle completed abort interrupt? Oh, I think it's just a timeout. I think it just timed out like yeah, because I paused it too long. But this might be enough to get us most of the way there. Ooh, on my page? What? Why? I read how? I guess it's not initialized. No, but it sent the mailbox. There's no way it's okay. One sec, I'll be right back. But what's going on here? Okay, back. What's going on here? This is weird. How did I end up... 455C is a weird address. That doesn't work. No, it does match. Wait, 455C is mapped. Oh, now we end up in device 2? Is the device also dynamic on the Dart? Ah, come on. Yeah, the stream ID is different based on whatever. Okay, what we're going to do is kind of cheat on this because this is kind of ridiculous. I don't really want to figure out how to do that. Hard ranks TTBR. Uh, if the TTBR is valid, I'll go with that. That did not work. Oh, was it commas or something? That. Ooh, okay. That fixed that. Not great, but it fixed it. That's a request probably for ver. And then we have missing trans ID. It's not packet, it's packet payload trans ID. Okay. Getting somewhere. And it seems to be not working though. Did I lose one of the... Oh, something went really wrong here on the getting messages. Something went very wrong. So that actually crashes it. I don't really get why that would be unreadable after startup, though. That doesn't make a whole lot of sense. Okay, let's try that. guess I can just make this not reread it if for some reason it's already there, but it's a bit weird though that it crashes on that. Oh, so that shouldn't even be in state. That should just be in self. Ring mem, yeah. Mem, ring mem base. Unmapped page. I did get the dart. I didn't find it though. Maybe it wasn't initialized yet. I'll put this in IO read. Let's make it simple for now. Okay, that works. And it looks like we got a lot of data, so that's good. Yep, I'm getting a lot of variables. That's good. Oh, I should make it. Ooh, and then another one of those. Why does it always do that? Wait, hadn't I been... Oh, because, like, Bluetooth is now using device 1 or something. Yeah, okay, what I just fixed should fix that, although I probably really should actually check the PCIe registers to figure out which one is which, but... another weird crash. I blame USB. What? Self-state. Oh, it's just self-ring info. Sorry. Ring mem dump ranks. Okay. What? Tracer state. I mean, I can just initialize them, but why? Why are we polling already if we haven't... Am I losing state? I think that's something that didn't trace somewhere. Oh no, yeah, it should. Yeah, we should always trace, otherwise it'll break some stuff. You always need to trace that, otherwise it breaks. Okay, reboot. Again? What? Why does that happen? That doesn't make any sense. It just dies. Okay, there we go. Now we're getting somewhere. No crashes or anything. I'm missing AWDL stuff, like, you know, all the Apple magic. Apparently you can get memory stats, which is nice. E-counters. Okay, so there's like statistics involved here, which is interesting. On PDU, counters, if counters. Let's see power stats. I just realized something, that if I like my Wi-Fi password is somewhere in here. Shrug. It's my public Wi-Fi anyway. Who cares? Okay, is this even on the Wi-Fi right now? Let's get this on 2.4. Would it be plain text though? For some ways of setting the Wi-Fi, yes. Let's go on a 2 gigahertz network and see if what does to Bluetooth coexistence. I actually just created that network, so I didn't have a 2.4 only network. Okay, it's on there. And let's grab a bit of let's grab the headers and okay. Ooh, SKU override. Interesting. That one. Oh, I'm interested in that one because some people said the Wi-Fi doesn't it doesn't perform as well as it should. And now I wonder if we're supposed to set like that SKU override. That's the antenna ID, by the way. Then it loads the CLM. We know that already, and it loads the TX cap. Loads the cal. Yeah, we know about all those. Interesting. And then there's some stuff happening there. Auto country. Scan force activate. Country code PR2G. VLAN mode. Interesting. TX profile. Core ether address. Bus. SSI event. Parents. Scan. Does some scans. Join pref. He's into delay. Scan map. PM2 radio. Shut. So I'm interested in first of all the Bluetooth coexistence, because right now Bluetooth sucks if you're on 2.4. Oh, BTC params. There we go. There's our Bluetooth coexistence. Yes, I've been wondering what that is. So what happened there? That's pretty small. It just sets some stuff there. .689A, apparently. That looks like a small message. Is that the... Yeah, no, that would be the set, I guess. Yeah, input, output. How do I do the RGB on Linux? What do you mean by RGB? Okay, so let's see if anything interesting happens as I poke around. So if I turn off the Wi-Fi, doesn't seem to do anything. Turn it back on. It's pretty slow to all the prints. Yeah. I guess there's a lot of like random info that happens. Let's get this Bluetooth paired with something. Where is Bluetooth? And see if we get any changes to the parameters when I get an audio device hooked up. Show Bluetooth in menu bar. Should be discoverable. Why is it not picking it up? That's not liking my my speakers. Why? Oh, okay. I think it was in the wrong mode. Maybe it's in pairing mode now. Oh, there we go. Okay, now it's connected. Oh, no VTC param. So maybe we just have to send that once. Maybe we just set that once and forget about it, and it just does the right thing. Can I play some music just to make sure that when it actually streams, I can see the volume bar. To just show sound in menu bar always. Mac Studio on mini hypervisor speakers. I love that. Let's pick that. Outputs on Core Motion Plus. Okay, you can just change it. Yeah, it is set. Not actually. Oh, play feedback when volume is changed. That's what I want. I think it's just the usual like stream taking a while to start up. Yeah, it does play. So it is connected, and there's nothing there. Okay, so maybe we just need to set BTC params like once. And that's it. It seems to just do it. Yeah, there's just this many times at the beginning. So the other thing I want to do is see if these are always the same. Bluetooth. Coex equals 2 is, I would like to know what that actually does. But maybe it's always the same. So this isn't really Bluetooth. You use the Bluetooth utilities. I think this isn't actually Bluetooth. This is like a Wi-Fi specific thing. Yes, the WLAN just has that. It's Bluetooth coexistence, not Bitcoin. So this looks like it's probably register value or something like that. Because we have 232-bit values. And it's 89A. So, okay, let's just try it. That's gonna be a very easy fix if that's what it is. The question is, of course, how do we gate that based on the hardware and all that? But let's give it a shot. So, Linux time. Linux. Drivers. We do have all that open. I think I actually tried this at some point, just trying random stuff, but I didn't know what the values were. I think I pulled some from something else, and it didn't make sense. So I think I was trying random things. Broadcom F Mac PCIe. DX cap. So first of all, do those get set? When do those get set? IE.add. Oh, do these get set for an interface? Okay. Oh, so maybe these have to be created per interface. Maybe that's why like my random experiments didn't work. Is this IEDAD a thing? Net wireless. No. I wonder what that is. Oh, IE and then something add. Sorry. It's not dot. It's like IE. Yeah. Let's see. What creates the interface here? Uh, let's try add. Okay. That is in field types. Yes. And that's probably wobble pattern. No, that doesn't make sense. Maybe it is that. And it does a IOVAR, IFP. Now that's still IFID 0, so maybe that's something else. Wait, hold on. BTC coax. Yeah, that is if ID is 0. So how does this create an interface? I know there's like an interface thing going on. Attach. Creates a Wi-Fi. Okay, so the BT coax attach happens. Because it does have some BT coax, but just not something that works for us. Yeah, so this does set BTC params. I just think it doesn't set what we need. Yeah. And that is what I thought, just 2 values, yeah. Okay, so let's just do that and set the things Apple sets and see if that makes it any better. BT coax attach. How do we get the interface from that? IFP config pub. Config pub 0. We get an IFP. And then we just write. Where's the attach? This is actually just doing some weird thing when DHCP happens. Um, oh, there's more. Okay, there's BTC parents, but then there's also BTC profile. Oh, that's... Oh. Okay, there's a big blob there. Where did that come from? Ah. Oh, no, that's getting info. That's getting info. Okay. Maybe that's just like garbage buffer or something. Okay, let's do the BTC parents first. So this is the 6F. Then 8C8. No, 8 AFC8. And then 3A98 on 9. And then A is 4E20. And there's the profile stuff. Interesting. Yeah, I think I remember seeing that profile thing and wondering what the arguments were. Clearly a lot of stuff. BTC profile active. Interesting. And then there's Wi-Fi prot, which is actually what that BT coax thing is doing. Are those really that long, though? What's that? BTC nothing? Okay. I do want to figure out if which like teleport reads and writes, because otherwise it's gonna get confusing. So will query command set command. Uh, that says command something. Ervar command get insert data get. he set var. Where is that? It's in foil H. Okay. Let's do that. Foil. Where are my trace? Whiteland. Let's just do commands here. Let's do a couple obvious ones. Okay, and so now that's in pointer request dot command. Okay, let's do it like that. We get the command. And then set var yeah, it just creates IOVAR, and that's just the yeah, it really is until the end of the buffer, so I could use construct again to get these. Yeah, it's not that interesting. Let's just try it like that. Get another log, and this time let's actually do let's look at it in real time as I mess around with the Bluetooth. I'm gonna turn off the speakers first. Why did it turn back on? I'll do that. Okay. So it just did VTC patterns at the beginning, nothing more. A bunch of them though. Wait, 6F, 8, 9A. Yeah, it's the same. Okay, 6, 8, 9A. Okay, then it did the Wi-Fi prot. Sets it to whatever that is. So where are we right now? That was probably when associating. Let's log in. No, it's still... Oh, okay. So it did that after association, probably because it's a 2.4 network, I bet. And then is connecting Bluetooth going to do anything? Are we connected to this or to something else? Because I have too many devices with the same. Yes, we are. Okay, so it doesn't actually care when Bluetooth connects, which is good because I really don't fancy trying. It does look like it does something. Oh, okay, I see. So it does set it to 2. It does set BTC profile active to 2 when audio is being played. Yes. Interesting. I mean, that makes sense, but that kind of sucks. Because it means that to do this properly, we need interaction between the Bluetooth subsystem and the Wi-Fi subsystem, and okay. So first, we have a good log now of all this stuff. What if I turn it off? Is it gonna undo something if I disconnect? No. Okay, so it just cares about when audio is playing. Um, and now let's try a 5 gigahertz network just to see if it's different. Interesting thing is that some networks are both 2.4 and 5, right? And I don't know if the card can roam like on its own or if it requires the host. It did do something. It just did the Wi-Fi prot thing. But otherwise it's the same. And then if I turn the speakers on, okay, it's connected. Oh, okay, so it doesn't engage anything on 5 gigahertz. Okay, so on 5G it doesn't care. But on 2.4 it does. Interesting. Okay, let's reboot that. We have a nice log of stuff. Oh, no, that's a response. Yeah, so the response is large for set val for some reason, but there's no get vars there. You do have those, so those are working. So they're all set vars. So it looks like Wi-Fi prot just gets sent once, so maybe it has a built-in timeout or something. But then there's the BTC profile stuff. That's a set var with all of Oh, I think it's creating a profile because look, it's doing number 2, and then it passes a bunch of data. Is that the coex2 thing that was in the device tree? Yeah, okay, it's coex2, so that probably means device 2, but sorry, profile 2. But then, where does the data for the profile come from? Maybe it's hard coded in the driver. Also, it gets sent multiple times. I'm not sure what that's about. Oh, there's 1, 2, 4. Okay, maybe those are the separate profiles. 0, 1, 2, 4. Interesting. Yeah, I think okay. I guess that's probably setting all the profiles. So in BT coex, it just sends those BT profile. Are those per interface or are those? They are if they are per interface. It looks like. Yeah, I don't know what's up with the return buffer, but yeah, I'd love to find out what these are, but I bet they're hard coded somewhere. It does say response len is like the whole thing, so I wonder what's up with all that data. But okay, let's get this data in here so we can see exactly what's going on. Yes, the X3 is the antenna SKU, which is interesting. That's coming back from the card. Good point. And I think this looks like the calibration data, but now I'm wondering if this is just like an initialized or something. Because I remember those patterns from the calibration. Yeah, see, this is in cal load. Has that kind of stuff, right? And look, it's just uninitialized, right? It's in the same offset everywhere. It's just buffer. It's just an initialized buffer. Yeah, it's just completely uninitialized. So the profile here, let's see how much of it is actually real. This X3 could be part of the real profile, but I know this data isn't. I think it might be 400, might be the real length, and this is just garbage. E counters. Oh no, there's. Oh yeah, that did change. So you have a 5 there. That is still there, so that's not part of the data. Let me open up two windows and compare. Okay, so it does change a lot of stuff there, including the X3. Oh, there's an X3 in E counters also. That might be moved data then. I'm not sure if E counters make sense. It could still be garbage. It does set SKU override, which makes me think this is important, but to country default X3, interesting. Chan specs, X3, extremes. Some of this stuff might be important for getting the wait, then isn't X3 just the country? Is it actually the antenna SKU? No, I think that's just the country. It's one of the country codes. It's just confusing because it looks like the antenna SKU. But the antenna, but it is X3. But I think that like Broadcom has those X countries things. Yeah, I think X3 is a country actually in this case. So maybe those are actually like countries. Okay, BTC profile. Either way, let's just get this data in. We can just say there's a big return buffer and we don't care. So let's do a bit of decoding of this structure, just sort of based on visuals. Can we do like little endian at compile time? Constant CPU LE16. That's what I want. Yeah. I don't think we had BTC profile in any of in these things. It's like BTC mode and BTC wire. BTC parents we know about, BTC flags, but no BTC profile. So, yeah. I don't remember this coming up ever in the past. No. Yeah, it's in their tools at least, but yeah, we don't know where they come from. Um, I kind of wonder if there's something that makes more sense here. Oh, the 2 is constant, and it's like that increments, so... So let's call it 1, 2, 3, 4, 16 byte headers. Yeah, okay. Let's simplify a bit. Say header 4, 1 byte index, and then we can just say these are 16-bit words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 1 extra padding byte. The only thing is that like putting the CPU thing constant is gonna be kind of annoying. I might just do it in code. What happened here? I think I moved something there. Okay. Oh, is this a length? Kind of. That might be a length. It's the total length, right? 28. Yeah, that's a total length. I don't know what the 2 is. Is this the length of... This might just be profile 2. So let's say it's LE16 profile. Is multi-monitor support on my to-do list for this year? It's on Sven's to-do list for this year. So that's probably a length. I wonder what the 18 is then. Is that a sub-length of some sort? If I do 18 from here, that stops there. Potentially there. Still doesn't quite add up. What about from here? No. Okay, let me try a bit of structure decoding. Uh oh. Oh, I get it. I get it. Yeah, so look at this. We have the profile ID or something. total length, packet length, including the header. Sorry, I got this wrong. I'm off by... A 0 is just a null. I'm guessing that's the profile ID. This is the total length. Packet length. Unknown. Some index. And then, is that actually right? 18. No, actually not quite, but almost. Maybe it's just the packet code. Yeah, maybe it's just like a header. That would kind of make sense. So let's call this a header, 18. Some unknown bytes. Index. And then some data. And then we have the, wait, 0008? Okay, yeah, then it's kind of, the header will have to be both. No, that doesn't make sense, because then the 0 at the end doesn't really terminate everything. Hold on. And then we have these two things at the end there, right? Maybe that's the number of things that come after it. Yeah, okay. Maybe I think the total length is right, but everything else is probably not right. Okay, I'm just gonna treat it as a bag of bytes after that index thing. So the profile ID, total length, the header, let's call that a let's call it a 32-bit. Let's put two of those. Header 0, header 1, and then we have the index, and then we have the params, which is one. Let's just say these are U8. 31, I guess. Yeah. And then a pad. Okay. And then we have 2, 3, 4. Yeah. It's called profile data. So we need that CPU to whatever thing. I guess it's that. I'm gonna define that. Two length is 28. Should be the length of the whole thing actually, but let's just hard code it. 5555 BA 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 BA. C4 C9. BA 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 BA. And then it's 7F. And that. Something like that. Bit of a tangent. Is RF work legal? I think it's just the Linux side of the drivers. And Broadcom are just incompetent and don't want to deal with Apple's firmware. I mean, if we do the same thing macOS does, it's going to work the same way as macOS does, so it doesn't really make any sense. It's probably because, like, people were using non-Apple firmware, and, like, the thing is supposed to use Apple firmware, and because releasing new firmware requires them to go through compliance again, they didn't want to do it, or something like that. But because we're using Apple firmware here, we don't care. Okay, let's see what the others are like. So just changes the 5 before the first 7 Fs. Wait, did I get that wrong? It's 0800, sorry. And then it's 80s. There's just 2 of them. Oh, sorry, that's the top one. Then 2 is the same. And then 4 is different. You know, these might be the profiles, and this might be like a version or something. I wouldn't be surprised if that's it. And then that's the index. And 4 changes the 5s to 6s. The first, all the ends to 28, and that's it. Does Zen hypervisor work? Zen is never going to work because it requires an ARM architectural feature that Apple did not implement in violation of the spec. Okay, I'll go with that. I don't actually know if this is necessary yet, but I'm copying it anyway. So we have these inits first. These come first. And then the Wi-Fi prot is probably when associating, and then it sets the profiles. So we can probably just do it here. Let's move this to another function. How does the right size work on Linux? Just like that. That. Just profile data. Make sure that's static. Static const. Apple profile data, it's fine. KVM does work. There's just some issues with QEMU because it assumes that all CPU cores are the same, which doesn't work on big little systems. That's a QEMU bug. You can disable the. I think the address spacing was already fixed in QEMU, and you can turn high mem off, and it does work. So, but the main issue is that like it gets really confused if you don't pin it to like the P cores or the E cores. Okay, prof. Is there upstream work to pin to P or E? I don't think so. But I mean, you can just use like task set. It'd be nice if it like automatically detected this case and did something insane though, but right now it doesn't do that. So BTC params. BTC profile. Uh, um, but it's what I actually want to do is like a set get type thing. Because the return data is pretty big. So how do I? It's query and set D command, but here it has both, which is weird. Maybe it doesn't matter. Maybe it really is just garbage that it's returning. Because isn't that the maximum? Isn't that the same logic? Where is that? Proto? No. Bus? Where is that? F frame lane plus FCS lane? That doesn't make a whole lot of sense. That's weird. Okay, be right back. Okay. Let me look at the log again. Just look for set var. Yeah, it's weird. It's oh, that's get var. Sorry. Oh, sorry. No, I'm. Yeah. Okay. Um. Yeah. So get var has different returns. Set var is always the same though. Yeah, these are always the same. This is weird. Why is this like the only set var that has a giant output buffer? Is that a bug? I mean, it could be a bug. Oh, this one, the event log get. It's really just padded though. It just kind of looks like it got padded. Oh, hold on. Oh, I might be actually like I might be getting responses wrong because I think I'm already yeah, because I'm not checking the interrupts. Yeah, I think that's probably happening because they're always on the same buffer, so I need to do something else. Yeah, so when we create the ring, let's just add a tracer on that. Okay, let's IO translate that. Make sure it's properly done. And I can add a tracer on that. Trace D2H pattern for sync. Oh, but that's already doing the hooks. Actually, you didn't just do self HV add tracer. It's iRange for ident trace mode sync. And then on reads of the actually I want to get the read index HA RP adder. No, the right one is the one I get, yeah. But I'm gonna catch reads of that. And then just pull on that. Let's try that, see if it makes more sense. It probably does. Read hook missing. Really? Oh. Wait, isn't it hook? Oh, no, it's not hook. It's event RW for the, yeah. Let's try that. Okay, that's not working. I think the reloads don't work for some reason. Let's just try that again. I need to figure out why that doesn't work, but I get the feeling the indices don't actually work properly. Is this actually working? Hmm. Oh, look, my Wi-Fi name is there now, so clearly this is garbage. Um, I think it's just nonsense. I think it's just a bug and like they set the wrong buffer sizes or something because it doesn't make any sense. Yeah, okay. So it basically does that on connect. Let's just send this stuff. Hold on, where am I? Here. I think there's an int set helper we can use for that. Var int set. Our data set. Yeah. IFP. Right, so let's go with 0 for now. Okay, and let's see if we can build this and do something. Linux. Getting hungry, so I think I'm gonna get dinner pretty soon, but let's see if this works. Actually, I'm gonna first do it without this. And we're gonna compare the performance as it is without the fix and with the fix. Something doesn't build. Apple profile data should be that. IFP undeclared. Why? Wait, was that even there before? Oh no, that's just garbage. I pasted there. Discards const. Yeah, it should be const. Okay, that works. And builds. Ooh, lots of stuff. Okay. I'm not gonna log anything. Actually, let's just do run guest kernel .Linux early con root wait. Yeah, that looks about right. Yes, Apple coexist. Like Apple invented something weird here. This is not standard in any other Broadcom device. It's something they did in their firmware. Okay. So let's see how bad this is without BT coax. How should I play that doesn't get me copyright blocked? First let's get the Bluetooth thing paired. Just probably gonna break the macOS pairing too, but whatever. Where's Bluetooth? What? No Bluetooth adapter was found? That's not right. Did I forget the driver or something? No, it's in there. Failed to load firmware. What? I thought I... Oh, because it's built in. I need the NetRunFS. Yeah, sure. We can do that. I think that one might have Bluetooth. I just need the firmware, so... Didn't complain this time. I think that's good. Hey, Bluetooth works. Okay, let's get this paired. And suddenly a lot more Bluetooth devices showing up. Hello. Can I find it? The issue is that it breaks Bluetooth. You're gonna see the issue. What should I play? What should I play? Something that's not gonna get me copyright blocked. Rick Probe would actually get me copyright blocked. Actually, yeah, we can do this. She doesn't mind if I do this. It's gonna suck though. Also, I'm gonna turn off my own music here because I do have Spotify in the background and that is a very low. How is the volume of 13%? Yes, you can hear that. That sounds fine. Because Wi-Fi is off and it's on Ethernet. So now let's get the Wi-Fi connected. So let's get 2G. And let's see what happens to the Bluetooth. And now it's gonna work, of course, just to annoy me. Hold on. Just refresh this or jump a bit or something. Okay, now it's gonna work just to annoy me. This used to suck, unless it only happened on laptops. Which would be interesting. Okay, now this sounds fine and I'm annoyed. Hold on. Why is this working now? Maybe speed test or something. Oh, wait. Ethernet is connected. It's probably not doing anything on Wi-Fi. Now we're on Wi-Fi. Nope, still works fine. Maybe it's mostly a problem on laptops. Oh, now it's stuttering. A little bit. It stuttered a little bit. But not much. Yeah, I know you can't hear it. It's on the side, but like, I'm waiting to reproduce before I like spam everything. Let's try 5G. Oh, also, Ethernet is like coming back. Let me unplug it. Let's see. I can loop this actually. Shouldn't I hide the IP? This is CGNet, so it's not even my IP. It's a bunch of people's IP. I don't really care. Like, you can't hit me coming on this IP. Okay, 5G works fine. Let's try the... Let's try that one. Maybe this just only sucks on laptops. This is on Wi-Fi. I actually have gigabit, but but I guess on Wi-Fi I get 200, which is pretty good actually. Yeah, because when I tested that this was bad, I was testing it on a laptop. So let's try 2G. It stutters at like a tiny bit when it starts. Yeah, 2.4 is terrible, isn't it? Yeah, I do have a laptop to test it with, but like it's not hooked up right now, set up so that I can actually do this. Um, so it's kind of annoying. I didn't actually turn it on, did I? No, it's commented out. Um, do I want to hook up a laptop? I can probably actually do that. Hold on. Um, oh, and this actually died, which is funny. Um, hold on. There. Okay, now it's like really confused. I did test with this speaker, and I think it was bad with this speaker. I also tried some earphones. I know it was bad with those, but I think it was bad with this one too. So let me try a laptop. See if I can do this. What laptop should I try? The M2 might work. And it should be the same kernel and the same everything. So let's see if I can just do that. Of course, I'm not gonna be able to see the screen now. I don't know if the partition is where I think it is. Let's try it. Yeah, it's booting. It's got something. Okay, let's try with the M2 laptop. Which is not actually the one I tried that I first repro this on. It was the M1 Pro, but it should be the same, right? I hope so. Okay, let's try the same idea. Oh, Bluetooth doesn't work now. Wait, does Bluetooth not work on the M2s? Oh, because the because the firmware I had extracted is not from an M2 and it didn't have the M2 firmwares. Right. Hold on. Is this actually? Yeah, okay, it's probably that one. HMFS firmware lib firmware. It's just copied on top. This might not even have SSH enabled. No. And of course now it hates me because of the host keys. One sec. And of course that is now slow because I'm on 2.4 giga. Okay, that is very slow actually. That's very yeah, I don't know why it took that long. That's the other thing, is that we might have issues with the Wi-Fi parameters and giving lower performance. So that's another thing to check. But for now, let's try that. And let's see if I can not with firmware. That. Don't need that one. Let's try that again. Do I have a stream deck to control the stream? I know I have. I just use like I use Barrier to unify my mouse and keyboard between different machines. So I just have I just move my mouse here to the left, and OBS is here, even though it's a different machine. I wonder if the channel width or MIMO is limited at the firmware level. We probably already spoke on this. People said they had issues with performance, like in terms of range and stuff like that. So I'm not sure, but I have a tracer now that I can see exactly what Apple is doing. So there's probably interesting things happening. Okay, Bluetooth is there. Let's pair it. Okay, now it's working fine, but I'm not using the Wi-Fi really. Speed test time. Actually, it's gonna work now. Okay, on download it doesn't matter. Well, I expect upload to be the one that really kills it, but wait, no, now it's on 5 gigahertz. Hold on. Okay, now it's on 2 gigs. Oh. Okay, now it dies. Like, completely. When I use the Wi-Fi. Like, you can hear that. It completely killed it. If I stop using the Wi-Fi, I think I completely disconnected, actually. So I guess the Mac Studio has, like, separate antennas or something. Yeah, so let's go back. Hold on. Why is this it doesn't? Oh, now we can add lovely.
Think.
2, 1. Skip. Why can't I right click? Oh, it's set for that kind of right click. Okay. I need to figure out what's. Yeah, I think it's probably the live input stuff not matching Apple properly. Um. Okay. Speed test. Oh, now it's working. Now it's working fine. Maybe there's like an antenna selection issue or something. Let's try upload. No, now it's working. Oh, okay, now it's glitching a bit. Or maybe it has to do with the codec. Hold on, let me check the codec settings. Okay, now it was on aptX. Let's try SBC, which probably chews bandwidth. Oh. Okay, glitched a bit. Let's wait for the upload. It's glitching a bit, at least. But not as much as I expected. So maybe there's like an antenna selection thing where like... the Wi-Fi just bounces between antennas. Yeah, there's beamforming involved for Wi-Fi, I know that. Probably for Bluetooth, actually. But... No, don't... Why are you... Give me something different. I don't think it's quite the beamforming, though. I'm putting it like in between now, it's not doing anything. But yeah, it looks like now it's skipping a bit. Okay, it's skipping a little bit. I don't know if you can hear that. Get the microphone closer. Not that much. Sometimes. Let's try another setting. No, that doesn't really change. Yeah, it's not consistently bad as much as I expected. Unfortunately. You see, sometimes it skips, right? Or maybe it has to do with the channels? No, but, I mean, Bluetooth channel hops anyway. It might be an antenna selection thing. Where it just like randomly like lands on an antenna. You can see that sometimes it glitches, but not. Yeah, but it's on the same channel. It's the same AP, so it's the same channel as before. So it doesn't make sense. I wonder if it's an antenna thing. I don't have IW. There's a set antenna. Is IW info or something? This one is 5G, 5.1 is... Okay, now it's glitching a bit. Oh no, there's only one 5N. Okay. I don't know what bandwidth it ended up in. I think I don't actually set it to 40 in my AP. Because I don't want to be evil. But hold on, let's see if I can... Okay, it doesn't support that, yeah. Yeah, it doesn't support that at all. Thing is, I think most of these like low-level things aren't actually supported in Broadcom FMAC, so you can see it glitches a bit, but yeah. Nah. Okay, let me just reboot. Try actually doing this. See if it works at least. And then see if I mean, I was glitching here. The M1 Pro Lab, the thing is, it glitched at the beginning, right? And then it just stopped glitching. Now, yeah. I mean, it's a different machine. It was the M1 Pro that I did the original tests with, but yeah, I could try it. Okay, let's try this again. Let's see if it doesn't glitch like at all now, even slightly. Even though I'm setting the profile to 0, which is not what macOS does when the Bluetooth is active, but at least I'm initializing. Is there any errors? No, that's good. Okay, let's see what happens now. So far, so good. Yeah, glitched a bit. I mean, some Bluetooth glitching, and like I'm in the middle of Tokyo, right? 2.4 gigahertz isn't great. But this does sound like coexist somehow working now. Okay, I guess try the M1 Pro as a last idea. That's not in my build machine, but let's see. I think it was really bad, like, for a second, right? And then it fixed itself. Nah, it's not the trace thing. Because I'm not actually tracing the Wi-Fi. I think it was coax because 2.4 was causing it to fail, and 5 was only glitching slightly, and then yeah. Okay, so let's disable coax again. Build that. I think that NVMe thing is right. Oh, wait, what? Oh, it's just like either that or something related to the firmware as being different, but I don't know. Okay, it's booting at least. I could try my earphones, but I have to search. I have to look for them. Okay, speed test. Oh, okay, it's gonna. Okay, okay. I think it's worse. Okay, it's definitely worse. Let's see if the upload really kills it. Clearly, yeah. Okay, that wasn't as bad. Let me try different places. Let's try SBC. No, it's still not that bad. it glitches at least. Just not a lot. I have an idea. Hold on. Okay, you know how I know BT coexistence is actually working? Because when I connect the Bluetooth, the speed test pauses and then, like, lowers in speed. It's doing something. Like, it just like to like half the speed when Bluetooth is connected. Yes, I don't know if these settings are right for this machine, but let's just see if it's any better with this stuff. But I might have to test out their Bluetooth devices and see if it's worse or something. I think my earphones were quite a bit worse, but I have to look for them. Not sure where they are. I wonder if it was the codec with those. I did save, right? It still glitches a bit. Sounds about the same to me right now. But I am on profile 0. So let's see if Let's see if doing that makes it any better. Actually, I'm not even sure if this code is getting called, so let's let's add a message there. Yeah, I might have to get out my earphones. I also remember AirPods were pretty bad. So maybe it's just like smaller receivers and stuff, and these large speakers are better. Unfortunately, if I can only reproduce it with earphones, I can't show you. But okay, I think Wi-Fi is slower now. Okay, there's one glitch there. Still glitches a bit. Okay, we're gonna call this inconclusive. I need to test other Bluetooth devices and see if I can reproduce a more reliably terrible experience. But I mean, the tracer works. I look at the other stuff later. The sleep mode stuff and the AP mode stuff. And yeah, we'll see. Also, I'm kind of curious about the sleep mode, so I'm gonna do one last test to plug this back into the studio and just try to sleep it and see what happens. I just want to see if there's any interesting messages exchanged or that mailbox thing. Quite curious about that. How much power the deep sleep CPU saves over normal WiFi? I think it should be significant. But I mean, it's pretty good with regular WiFi, so. Let's make a separate log for that. I'll be right back while that boots. Okay. We are booted. I could have just hit sleep on that screen, but let's see. Sleep. It's actually gonna sleep. Did something. Wi-Fi still being busy. Yeah, so look, it's doing the like offload stuff. Ooh, there's like a blob it downloads for the NDNS stuff. Okay, but I'm interested in exactly what it does at the end of the sleep mode. Yes, and that killed the hypervisor, which usually happens. That's fine though. The question is, what was the last thing it did? Thought so. It's the mailbox. It uses this for the mailbox. And what are the actual messages exchanged? Now it rebooted, but that's fine. Last thing in the log here. What does the regular, like the existing Linux driver do for the mailbox? Enter D3. It sends mailbox data, D3 in form, and then it waits for the ACK, inform and use inform. It's just one. And look, it sends 20, which is something else. Gets back an ACK. It sends a 2, which we don't know what that is. Enter, DS, enter request. And it sends a DS ACK. Okay, so that's the Wi-Fi saying request enter deep sleep, ACK enter deep sleep, and then 4, and then it does a deep sleep exit for some reason, which, oh wait, no, because this sent to 40, whatever, and then it does a D3 ACK, supposedly. No, wait. Yeah, not sure what that one's about. D2H, H to D20, D2H2. But then finally it does H2D1. And that one is D3 in form, which is the one we care about. And then it's waiting for MB data completed. And that is set on D3 ACK, which is also 1. So there's some weirdness before that, but this part with the D3 is exactly the same as what the Linux driver does, just with these stupid ring buffer messages instead of the like physical mailbox register. This is macOS. So that's okay. That answers everything. It's exactly what I suspected when I saw those messages. They moved the physical mailbox to the rings. That's yeah, I guess that's it. All right, if I start messing with sleep now, I'm not going to get dinner. So next time, I will try this and see if it works. And also look at access point mode, which at least is reproducible because that just doesn't work. And see if I can find some Bluetooth devices that like consistently suck. All right, thanks for coming. That was a decently productive stream. I'll see you next time. All right. See y'all.